Hey everybody, today we are going to continue solving problems from LeetCode's list of problems called Top Interview 150. We are at the third problem, remove duplicates from sorted array. Let's open that and see what it is about. The name kind of makes the problem obvious, but let's still make sure we understand the problem. Okay. So remove duplicates from sorted array. Given an integer array num sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Okay. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following. Okay, change the array num such that the first k elements of nums contains the unique elements in the order they were present in nums initially. Okay, and then the remaining elements of nums are not important as well as size of nums, and return k. Okay, so I think this is very similar to the previous problem we did actually. That's why I went through it a little bit more quickly in reading it. And the previous problem we did was remove element, which was given an array and a specific value. You have to remove all the occurrences of that element from that array in place. If you don't know about that problem, or or don't know what I'm saying, then please go look at my previous video, and that's where I have uploaded solving that problem. But anyway, this is similar. I think basically we are given an array and we have to remove certain elements. In this case, the element to be removed are the ones which are repeating next to each other because they are sorted in non-decreasing order, and we have to do it in place. And whenever we do some things in place in an array which modifies the size of the array, especially makes it smaller than in programming languages which do not allow making arrays bigger or smaller, at least not in place, you have to return the logical size of the newer array. So it's similar to that. So I'm zipping through that a little bit. The custom judge is just some code they have given that will, judge our code. This is the code, template code that's already there, which will run our code. And if all assertions pass, then our solution will be accepted. Again, very similar to the previous problem. They have given the judge code there. Examples 1, 1, 2. If 1 repeats, so we have to remove that. And then we say 1, 2. Here it could be anything. It could be the extra one, or it could be junk, or it could be the 2 that was originally there. We don't care. 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. Yeah, 0, 1, 2, 3, 4. And again, like the 5 extra spaces can have any values in there, but the important thing is we return 5 because that's the number of values which actually logically make sense. Cool. There are some constraints they have given. Let's very quickly go through that. The length is between 1 and 30,000, looks like. Length of the array, I mean. And the value of each element in the array is between -100 and 100. Although those constraints are not really hard to, it's not hard to write code which work without those constraints as well, but then the same code works, but they have given them just in case they are useful. And nums is sorted in non-decreasing order. So they've restated the last one again. Okay, so like I explained in my last video, I'll go through that one more time just very quickly, just to rehash that. Every time we are doing something like this in an array, the way to think about the algorithm, maybe the algorithm was obvious, but I just want to cover it very quickly, is that, for example, if you take one example, let's take the bigger example of the 2. Let's say this one, and we are removing elements. Think about, before doing it in place, think about what if you returned a different array which contained the result. So sorry about that. 0, 1, 2, 3, and 4. If we did that, how would we do it? We would actually, the way we would do it is we'll actually go through each element in the given array, which let's call it source array, and by keeping a source pointer. And if that element is not the same as its previous element, we'll copy to the destination array. So we'll keep a source pointer, we'll keep a destination pointer. So initially, imagine that there are enough spaces in the result array we have not constructed it yet. And the destination pointer is pointing here, and source pointer is pointing at 0. Since 0 is a new value, we just copy it to destination, move the destination forward, and we move the source forward always. We look at this value at the source pointer again, it is the same as the previous one, so we do not copy it to destination, and hence we do not move the destination pointer forward. But we again, of course, move the source pointer forward because we have already looked at 0. Now 1 is a new element, it's not the same as its previous, so we say, okay, hey, let's copy that to the destination, move the destination forward. Now destination is here, and here source moves forward. And you get the point. So similarly, this one will be skipped, this one will be skipped, and so on without moving destination, but this 2 will actually copy 2 to destination and move the destination forward, and then 3 and then 4. So that is how we would do it if we were actually copying all the unique values into a different array. And like I said in the last video, it turns out that the same logic works even if you do it in place, even if it is not a new array. And that is kind of what we are going to implement. And the reason it works is because, source keeps moving forward every time, but destination pointer stays behind where the next location for the new element is, and we can very safely override that because destination will be ahead of all the values that have to be preserved. So the same logic works, so I'm going to remove this comment. The only thing that differs from last solution is how do we what do we remove? We don't remove a given element, we actually remove duplicates. Now before I jump into code, one more tiny thing I want to cover here is, like, whenever there is a thing about comparing to the previous element, there is always an edge case, right? And the edge case is the first element. So there are a couple of ways of handling edge case. One is that we have an explicit if condition inside our for loop. So for example, if we wrote our for loop source index equal to 0, source index is less than nums dot length plus plus source index. We know that we have nothing to compare to for the 0th element. There is no previous element for 0, right? So int priv index equal to -1. There's nothing to compare to, like there is no -1 is there. So we could here say if priv index is not equal to -1 and then source index, source of source and so on. But so we could do that. But in this case, basically there's special logic, but it runs on every iteration, right? It only is needed for one iteration. Sometimes it is not avoidable, but in this case it is. And all we do is we basically start from 1 because it is in place. The first element is already in the right place. So we don't even start from 0, and that is what makes it work. And what we do is we say previous value or previous index. Doesn't matter if you make it previous value or previous index. Let's just call it priv value equal to nums of 0. Yeah, and so that's what that is. Now again, since we are accessing the 0th element, we need to make sure that the nums is not an empty array, and that could be a valid input. So maybe instead of doing that, let's just do priv index equal to 0. So we don't have to worry about that. Okay, so now what we just do is we say, okay, hey, we need a destination index. Dest index equal to also 1. Since we are starting source from 1, we'll start destination from 1. Okay, and now all we need to do is we need to figure out whether the current element we are at, which is what, nums of source index, is it the same as previous element? Okay, if it is not the same, is not equal to nums of priv index, then we copy it to the destination and move destination forward. Then we say nums of dest index equal to nums of src index, and of course we move destination forward. Only in that case, we don't always move the destination forward. And we always make priv index equal to source index after we have already looked at the previous element. So at this point, after the loop, dest index would contain the number of elements in the number of unique elements in nums, Again, the only case we have to figure out is what if nums was completely an empty array of size 0, then dest index would have started with 1, um, which is not ideal. So actually, then we have to add a special case. So I think one other thing we can do is, instead of doing that, we can start dest index at 0 and do plus plus beforehand. Only if we found a new element to be copied, then we move the destination forward. So what happens is, if we start at 0, we are saying, oh, we found a new element to be copied to the destination. That's where we increment the destination index, and then we actually copy into it. So this probably will take care of the special case where, let's make sure it does. So if nums is a completely empty array, which means its length is 0, in that case, this will be initialized to 0, 0, but this loop won't run. And since the loop won't run, it will say, oh, the number of elements in this array which are unique is 0. Okay, yeah, I think that works. So that avoids our any special if conditions for special cases. I think that is pretty much good. I am ready to run the code and see how it does. Maybe there is, I hope there is no compile errors. Okay, it says wrong answer. So I do have some bug. Expected is 1, 2. Let's see what I did. Destination started with 0, source index. Wait, what was the example? 1, 1, 2. Okay, source index equal to 1. Okay, and then at that point, priv index was 0, and it should be equals, so it shouldn't move forward. Okay, priv index equal to src index. That's always the case. We always want to make that the previous index. Okay, so that will move to 1. So the second one should be skipped, but dst index should be at 0. Okay, and at this point, it will be pointing, the source index will be pointing to now 2, 0, 1, and then 2. And in that case, it is not equal to, it should be not equal, so we increment it and we copy it, and priv index equal to source index. Okay, so what went wrong there? And I think I need to run through it slowly. One sec. Oh, I think that's because I returned dest index as, yeah, I am incrementing, post incrementing it. And so this will be 1, even though we copied into the correcting. Okay, so that special case is unavoidable. So I'm gonna, yeah. So yeah, that will not work. It's the same thing. We need a special case somehow. So we can go back to how it was just to keep it clean. But here, I think we just have to handle it as special case. That if I was trying to avoid that, but it looks like either ways we need it. And then return 0. Okay, and now this should be fine. Let's run that. Yeah, that makes sense. Yeah, that's the fun of programming. You try to avoid special cases as much as you can, and then you realize for some reason it doesn't work. Yeah, I think I just want to add one test case myself where all the elements are kind of duplicate. So let's see, 1, 1, 1, 1. Let's see, it should return 1. Yep, there you go. Hopefully that was clear. Like I said, it was very similar to the previous problem we did. Just the logic of when to copy and when to skip depends on the previous element, versus in the other problem, the logic dependent upon a given value. Okay, see you guys next time.